Good morning, guys. Hope everybody's doing well. Hope everybody had a nice weekend. So today, this is the lesson for today, Monday, March 23rd. Okay, how do we create, read, and interpret a stem and leaf plot? All right, so let me walk through everything that you need to do for this lesson. Let's take a look at the do now. The first thing we have here is it says that you decide to get odd jobs for the summer and you keep a log of your daily earnings. In 1 month, you earned the following amounts. So you see there we have the amounts listed from $12, $9, all the way through, and it ends at 15. Question A asks for the mean, median, and mode of the data. So before you can pull any of that information out, we need to order the data from least to greatest. So notice that I already did that just to save a little bit of time so that this video is not extremely long. Okay, so we order the data from least to greatest. To get the mean, remember that's the same as the average. We're going to add everything up and then we're going to divide by the number of data that we have. There are 20 numbers here. So the sum, when we add everything up, the sum is 288. All right, and we're going to divide that by 20, and that gives us 14.4. So the mean average is 14.4, and since we're talking money, it's $14.40. Remember, guys, that the median is the middle number. Now, if we have 20 numbers in our data set, that means that the median is going to fall in between the 10th and 11th numbers. And the 10th and 11th numbers can be found here at 14 and 15. When you have an even set of numbers like this, what you do is you take the two numbers that are in the middle, find the average of those. So the average then would be of 14 and 15 would be 1450. So you can take 14 plus 15, you get 29, okay? 29 divided by 2 is equal to 1450. Also notice when it's something like that, when it's two numbers that are right next to each other, it's literally just the middle, right, what's in the middle of those, which is 14 and a half, okay? Or in this case, 1450, since we're talking about money. The mode is going to be the number that occurs most often, and in that case, it is 15. Okay, $15. Question B, describe the shape of the data set. Is it symmetric or are there extreme values in the low or high numbers? We do have extreme values. Okay, so this isn't really symmetrical. We do have high numbers. Our extreme values would be 6 and 25. Okay, because that's a really wide range of numbers. Okay, think about it. Remember, this is your daily earnings. So one day you earned $6 and another day you earned 25. All right, so that's a pretty wide range. Question C, what was your average daily income? If you worked approximately 4 hours a day, what was your average daily income? Okay, so now this question, first part, what was your average daily income? That's going to be the same as the mean. Okay, so for part C, your average daily income, okay, average, I'm going to put this as ADI. Average daily income is $14.40. And now for this part, now regardless of how many hours we worked, our average daily income is going to be the same, okay, $14.40. If that word daily were changed to hourly, okay, if instead it said hourly, our hourly income, our average hourly, income, given the fact that we're assuming that we worked 4 hours a day, what you would do would be is divide 1440 by 4, and that would give us $3.60 per hour. Okay. For homework, it says to complete the worksheet. Now, I'm not giving you homework each day. Okay, you guys working on these questions is enough. You don't need classwork and then homework on top of it. Remember what I had said. I will be giving you a weekly assignment This week's assignment is going to be completing the practice test. Again, it's not going to be counted or graded as a test. It's going to be counted as completed work. Okay, but you will be responsible for completing that practice test on big ideas by Friday. Okay. All right, so let's talk stem and leaf plot. This is the definition here. A stem and leaf plot is a special table where each data value is split into a stem, which is usually the represents the first digit or digits, and leaf, which is usually the last digit. Leaf, most of the time, is going to represent the ones column. So think of the leaf column as your ones column. The stem is going to be the tens, hundreds, or thousands going on from there. Okay. So for example, in this stem and leaf plot that we have here, okay, take a look at this first number, the first row. We have 13, a line, and then 6. That would represent the number 136. Okay, so that would be the numbers that we have in our data. For the next row, 14. So 14 and then 1, that would equal 141. So this row here, that means that we have 141, another 141, 144, and then 146. Okay, you see what's happening here now? This would be 153, 158. All right, over here, let me just write it so that it's not getting all squished. 165, 168. All right, you see what's happening here? Notice in in row 19, we have nothing here. That means there are no numbers in the data set that begin with 19. Okay. So no numbers here. No numbers here. Okay. And keep going on. You have 205, 211, 218, 220, 222, 226, 228. 226, 222. And this is 220. So when you see a 0, it doesn't mean that there's nothing there. That actually stands for a 0 in the ones column. Okay. So let me just add that here to the 180 so that we see that that's 180, 186, 187. Okay. So here we have, it's the same stem and leaf plot on the last, that we had on the last page. Question 1, determine the minimum value, maximum value, and range. The minimum value, now you notice that the stems, they're always written from least to greatest. Okay, we have 13 all the way down to 22. And then the leaves going from left to right are also going to be written from least to greatest. The minimum value on this stem and leaf plot is going to be 136. The maximum is going to be 228. And then remember how we find the range. We're going to subtract the highest, okay, from the highest and the smallest, the largest value and the smallest value. So find the difference between the largest and the smallest value. Okay, so in this case, we're going to do 228 minus 136. Okay, and when we subtract that, 8 minus 6 is 2, 12 minus 3 is 9, so the range is 92. Okay, question number 2 says determine the count, the median, mode, and mean of the data. Round the mean to 1 decimal place if necessary. The count refers to how many numbers we have in the whole data. So the way that we do that is simply counting the number of leaves. Okay, go through, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have 22 numbers in our data range, in our data. The median, remember, is the middle number. Okay. And if we have 22 numbers all together, the median is going to be found in the middle of the 11th and the 12th. Okay. So we can start counting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is going to be in between the 11th and 12th number, which is going to be the 173 and 176. So let me just put that here. Median is between, I don't know why that keeps happening. Hold on. Median between 173 and 176. So now we want to find the average of those two. So 173 plus 176. Okay, add those two together. And let me write it vertically. It's going to be a little easier to do that. Okay, let me write. Uh-oh, it's going up. 173 plus 176. Okay. That gives us 249. And we want to divide that by 2. So 249. Divided by 2. 124. Okay, 124.5. So the median then is 124.5. Okay, the mode is the number that occurs most often. So it's pretty simple to find here. Okay, what we're going to do is look to see which of the leaves appear most often. Okay, and that looks like it's going to be 141 because we have 2 1s there. So the mode is 141. And the mean or the average, and how are we going to find the average? We're going to add up all the numbers and then divide by the count. Okay, so you have all these numbers here that we want to, it might be easier if you write them out if you want, okay, to add them all up. We have 136, 141, 141, 144, 146, 153, 158, 165, 168, 172, 173, 176, 180, 186, 187, nothing for 190, 205, 211, 218, 220, 222, 226, and 228. I'm just going to count to make sure I have 22 here. 22 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 22. Okay. Now we want to add all those numbers up. Okay, so the sum I got is 3,956, and then we're going to divide that by 22. and that gives us 179.81, and it says round to the nearest decimal, so 179.8. So the mean or the average is 179.8. Okay. How many values are greater than 190? So since 190 would fall here, okay, these all are greater than 190. So all we have to do is count the leaves. It's 1, 2, 3, 4, 5, 6, 7 numbers. 7 numbers that are greater than 90. I'm sorry, 190. Okay. How many values are less than 151? So 151 would be above the 153, 158. So we would count these two. 1, 2, 3, 4, 5. So we have 5 less than 151. Okay. All right. On to the next problem here. It says the table lists the maximum running speeds of various animals. How can the data be displayed to show the distribution of speeds? Create a stem and leaf plot. Okay, so here I'm going to show you how to create the stem and leaf. It's really simple. Again, the stem is going to be here because we're dealing with just all numbers that have a ones and a tens place. The stem is going to be the tens column, and the leaf is going to be the ones column. What you want to do is look for the smallest value and the largest value. The smallest value is 32. So I'm going to start the stem with a 3. And the largest value is not a 50. It's actually 70. So we're going to go up to 7 on the stem. So 3, 4, 5, 6, 7. Now, even if I don't have a number within a certain tens, like let's say I had nothing that fell, nothing that's like 60, nothing in the 60s, I'm still putting the 6 in the stem. That's important, okay? Now I'm going to go on to the leaves. You want to organize the leaves from least to greatest. Sometimes it's a little bit difficult if you have a lot of data to do that. You can start by just writing them down as you go and crossing them out, and then organize them when you're all finished at the end. All right, so let's take a look at our numbers in the 30s. We have here 32 and 39, so I'm going to put 2, 9. Okay, 32 and 39. In the 40s, okay, so I have 40, 43. So I got 40, 43, 45, and 47. So I'm going to put 40, 43, 45, and 47. Okay, 40, 43, 45, and 47. The next one is 50. I have just 50. I have no 60s, and I have 170. So that's what your stem and leaf plot is going to look like. Okay. And we can title this maximum running speeds of certain animals. Maximum running speeds of animals. Okay. And if we want to create a little key, it's always good to have a key. I'm going to put here 3 and then 2 equals 32, because I want my readers to know, or whoever's looking at this, that that's equal to 32, not 32,000 or 32 million or another number. Okay. And that's it. That's it for your stem and leaf plot. Okay, the next couple of problems, even though they say homework there, like I said, I'm not giving you homework. This in and of itself is enough homework for you guys to do. I have the solutions worked out for you here to take a look at, okay? If you want to do more than this problem here, the bicycle stunt, feel free, but I'm not requiring it, depending on how long it takes you, okay? And you know, if you want, provide me with some feedback to let me know how long some of these lessons are taking you, because I really don't. I know that you have all of your other classes to do as well, so I don't really want to completely overwhelm you with a ton of work. Okay. All right. So for the bicycle stunt competition, this problem is just slightly different because it involves decimals. So we're going to do something just slightly different here. Notice instead of the stems representing or standing for the tens place, it's actually standing for the tens and the ones, and the leaf column in this case stands for the decimal place. Okay, so just slightly different, but still, you know, for the most part the same. The conclusion here that we can draw from this is that the most common points were in the 89 range, and most cyclists scored 89 or better. You can see that from the flow or where the information is more concentrated. Okay, up top in the 84s, 85s, you don't have that much. It's more concentrated below 89, 90, 91. Okay, this problem here, the test scores for the students in the social studies class are listed below. Make an ordered stem and leaf plot of the scores. So there's your stem and leaf plot. Okay, again, same thing. We're dealing with the stem is representative of the tens place. The leaf represents the ones column. Notice that we go from 6 all the way down to 10. Okay, because we have the numbers, scores from 67 is the lowest test score and 100 is the highest test score. Question number 2 asks, it says, use the stem and leaf plot from exercise 1 to determine the number of test scores greater than 84. So we go over to the leaf. Okay, you're looking at this row, the 8 row. Okay. And the numbers that are greater than 84 are going to be 86, 88, 89, 89, 92, 94, 96, 98, and 100. Okay, so that means that we have 9 scores that are greater than 84. Question number 3, use the stem and leaf plot from exercise 1 to make a conclusion about the test scores. There are a couple of conclusions that we can make from this. More than half the class scored in the 80s and higher. Okay, the other conclusion is that the lowest test score was 67 and the highest was 100. Right? And again, you see where the data is most concentrated. And that, again, is really the purpose of a stem and leaf plot. It's one other way to organize your data and to see where the data is most concentrated. Okay, where is it, you know, where are the most common numbers falling. Okay. This question here says the ages of the people at your family reunion are given in the stem and leaf plot. How many people attended the reunion? Again, in order to find how many people attended, you're just, all you have to do is count the leaf columns, okay, the leaf side, and we get 26 from that. How old was the oldest person there? 61. Make a conclusion. The conclusion that I see here is that most people were younger than 40. Okay, you can state some other conclusions that you may have seen, such as there were 2 people that were in their 60s, there were 2 people in their 50s, there were 2 people in their 40s, and so on. You could say that there were 1, 2, 3, 4, 5 kids under the age of 10. Okay, there were 1, 2, 3, 4, 5, 6 teenagers, and so forth. Okay. All right, last question has you comparing two different stem and leaf plots. Okay, use the heights in inches of plants grown using 2 different fertilizers. So we have organic fertilizer and chemical fertilizer. We made a stem and leaf plot for each. Okay, on the left we have the organic and on the right we have the chemical. Once you completed that, you had to make a conclusion about each. So if you're looking at this, notice again where the data is most concentrated for each fertilizer. Okay, for the organic, you have the majority of your numbers being concentrated towards the higher numbers, the larger numbers, okay, 30 and above. The chemical fertilizer, the numbers are more concentrated between 0 and in the 20s. So those conclusions that can be drawn then is that plants grown using organic fertilizer grew taller than the ones fed with chemical fertilizer. Which leads us into question number 3, which of the 2 fertilizers are more effective? Again, that pretty much is similar to the question that if you came up to that conclusion in number 2. Organic is more effective because the plants grew taller. And sum it up. How do we create a stem and leaf plot? So remember that your leaf column represents the ones digits. Stems represent tens, hundreds, or thousands, or more. But we're really not going to see that at this point. We're really only going to be dealing with the tens or the hundreds column. And what is the purpose of a stem and leaf? It's yet another tool and another way for us to display the data so that we can see how the data plays out. Where is it more concentrated? And that's pretty much it. Okay. If you have any questions, don't forget you can always contact me during the office hours. My office hours are 9 to 10:30, 12:30 to 2. All right, you can email me, you can text me on Remind, you can even message me on Hangouts or video conference on Hangouts as well. All right, have a great day, guys, and I hope you found this video useful. Look forward to seeing you soon.